Hello guys, welcome to my YouTube channel. In this video we will discuss about different types of illumination techniques that are used in slit lamp examination for diagnosing different type of disease. The slit lamp biomicroscopy is an examination used to observe the anterior and posterior parts of the eye. So, slit lamp biomicroscopy is an examination used to observe the anterior and posterior parts of the eye based on the position of illumination arm and viewing arm. Different examination techniques. So types of illumination techniques. So there are two types of illumination, that is direct illumination and indirect illumination. So first is the direct illumination. In direct illumination, the observation system and illumination system are focused at the same point, and in indirect illumination the observation system and illumination system are not focused at the same point. So the first is diffuse illumination. In this type of illumination technique, a diffuse filter is used. So diffuse illumination is a part of direct illumination, that is in which a diffuse filter is used. A wide open beam is directed onto the eye at an angle of 45 degree and the magnification is 16 to 10x. So in this technique we used a wide open beam that is directed onto the eye from the angle of 45, used to determine general features such as color, size, oval or all, survey of eyelids, lid surface, caruncle, sclera, surface vessels and media opacity. So all these things are can be observed by using the diffuse illumination. So we can observe the color of iris, color of sclera, eyelids, caruncle, and different types of media opacities, vessels, vascularization. So all these things we can see by diffuse illumination. So this is a picture showing the diffuse illumination. In this picture you can see the this is the observation system and this is the illumination system, and this is on 45 degree, and this is the cornea, this is the ciliary body, and this is the lens. And in this we are observing the cornea, and our illumination system is also focused into the cornea. So this is the example of diffuse illumination, or this diffuse illumination is a type of direct illumination. It is also used to observe vascularization, as I told you, epithelial edema, etc. Now we will discuss about the direct focal illumination. In direct focal illumination, the observation system and illumination system are focused at same point. So as I discussed that in direct focal illumination, the observation system and illumination system are focused at same point. There are three types of direct focal illumination, that is, the first one is optical section, knife like horizontal section of the cornea, lens and anterior vitreous use the narrowest beam. So in optical section, this is a type of direct illumination. In this type of illumination we will use a narrowest beam. So the beam will be 1 mm to 2 mm thin, and then we will observe a particular part of the eye. For example, if we want to observe cornea, then we will take an optical section of cornea, and then we will observe different types of features of the cornea. For example, corneal thickness, corneal vascularization, corneal layers, etc. Now, in optical section, two beams will be seen, one curved beam outlining the surface of cornea and another other a flatter unfocused beam reflecting from iris surface. So in optical section we will get two beams. One beam will be seen on the surface of cornea, that will be curved because our cornea is dome shaped, so we will get a beam will be curved, and then it will outline the surface of cornea, and we will get one more beam that will be on the that will be flatter and unfocused. So the first beam will be focused on the onto the cornea, and the another beam will be flatter and will be unfocused beam. So the another beam will reflect from the iris surface. So the optical section of the cornea to determine thickening, thinning or distortion of the corneal contour. So in optical section of the cornea we will determine the thickness of cornea. We can observe the thinning, the areas of thinning of the cornea, distortion of corneal contour. So these all things can be observed by using an optical section. So in optical section we can observe the tear layer. So we know that we have the tear layer in the surface of cornea, so we can observe the tear film, also epithelium, that is the first layer of the cornea, and we can observe a dark line, that is epithelium. Bowman's layer, this is the second layer, appears as a bright line. Then the stroma appears as a gray granular area. So stroma is a granular area and it will look like appear as a gray. It is gray in color. And stroma, as you know that stroma covers 90% of the cornea. So the most of the area is granular, and you can see this is the stroma layer. The endothelial zone appears brighter than stroma. So endothelium is the last layer of the cornea and it appears more brighter than stroma. To access depth of foreign body lessens depth of opacity. So we can also observe in an optical section of the cornea the depth of foreign body, that the foreign body is on which layer the foreign body is penetrating, on which layer, and lesions and depth of opacities also. Now we will discuss about the optical section of lens. In optical section of lens we will move the joystick forward in order to focus light onto the uh, surface of lens. So as you know that in optical section this is a type of direct illumination, so the observation and illumination system will be directly focused onto the part that we are observing. So we will take optical section of the lens and we will direct our illumination system onto the lens, and we will make a optical section of the lens, and then we will move the joystick forward in order to focus light onto the surface of the lens, and we can observe the various layers of the lens. So as you know, we can observe the lens nucleus, lens capsule, and different type of opacities of lens. We can also create the nuclear sclerosis by comparing the color of nucleus, whether it is grayish or greenish, and it becomes more yellowish and brownish towards the harder grading of cataract. So as you know, nuclear sclerosis is the grading of cataract when opacity of lens nucleus is called nuclear sclerosis, and we can grade by comparing the color of nucleus. If the color is grayish or greenish, it means it is the grade 1 or grade 2, but when it become more yellowish and brownish towards the harder grading of cataract like plus 3 plus 4. So these gradings are harder grading of the cataract. Now optical section also give information about vitreous behind the lens. So optical section also give information about the vitreous. We can also observe the vitreous cells by using an optical section. Now we will discuss about the parallel pipe beam. So generally a very wide beam is used for surface study. A very narrow one is used for sections. So we will use parallel pipe beam for observing the different surfaces of the eye, and in parallel pipe beam there are two parallel beams are formed, and these two parallel beams are generally very wide beam, and narrow one is used for sections. A useful combination of two is the parallel pipe section of the cornea, which uses 2 mm slit width, enabling corneal surface as stroma to be studied. So by using a parallel pipe beam, we can also study the corneal surface and stroma layer of the cornea. Now we will discuss about the conical beam. So conical beam, this is the round beam, circular beam used to access the flare and cells pigments in the anterior chamber. So conical beam is mainly used to observe the cells and flare in case of inflammation, and this is based on the Tyndall phenomena. Small circular beam, so beam is very small and circular, project through anterior chamber at 40 to 90 degree angle. So the illumination system will be situated on 40 to 90 degree angle, and our up to the and the best reflection happens at 90 degree. So now we will discuss about the tangential illumination. Elevated abnormalities of the iris tumors are observed. So tangential illumination is used to observe the iris elevated abnormalities, cyst tumors, etc. Now the specular illumination, it is a type of surface reflectance often described as a reflection of light from the surface as smooth as mirror. All incident light is reflected into a single outgoing direction, and we will get a bright dazzling glow. So in this image you can see the specular reflection, and this is the diffuse reflection. So always we need a smooth surface for the specular reflection. In this the rays are coming for here, and this is the incident light, and this is the reflected light. So these both are the angle of incidence or angle of reflection are in same plane. So this is the specular reflection, and here you can see the diffuse illumination, the incident ray in the angle of incident and angle of reflection are both different, and the illumination is diffuse illumination. So this is the main difference in specular and diffuse illumination. And in specular reflection we will get a bright dazzling light from a smooth surface. Now the principle of the specular reflection is that angle of incidence is equal to angle of reflection. So quality of reflection is equal to the surface quality of the reflecting surface. Now the observation and illumination have same angle on perpendicular axis. So here you can see this is the cornea, and this is illumination system, observation system, and the light is going to be focused from here, and the light is, and we are observing from here. So this is our specular reflection. Now we will discuss about the monoocular method. Reflected light should pass through only one eye, and therefore the method is monoocular. So specular reflection can be seen more easily in by uh, uh, by only a single eye, so it is a monoocular reflection. Now we will discuss about the use of specular reflection. So movement of lipid layer of the cornea, tear meniscus, irregularities of anterior cornea, corneal endothelium, contact lens wettability, these all things can be observed by using specular reflection. So this was all about the some techniques of slit lamp. So these all are direct illumination. In next video we will discuss about the indirect illumination. If you like this video, please do subscribe and share to my YouTube videos. Thank you.